The next packet in Unit 7 is Unit 7 Packet 2, Significance Test for Means. So for this test, we are going to be running a one-sample t-test for a population mean. So we are talking about the population when we are given a sample. So we take a sample and we use that information to generalize for the population. The first part of this packet requires us to be able to state the hypothesis. Very similar to Unit 6, Packet 2, we have two different hypotheses. The first hypothesis is the null hypothesis, and this is the claim that we're weighing evidence against. This is going to be the claim that the company or the study makes, and it always refers to the population, so we use mu, not x bar. So when you're making your null hypothesis, the symbol does matter, so your null hypothesis will use mu. Your alternative hypothesis is the one we are testing or we're trying to find evidence for. Again, we are going to use mu, and you have two options here. It can be two-sided or it can be one-sided. So two-sided means that it could be more than or less than. It's just not equal to whatever the population mean is. Or it could be one-sided. So for example, it says mu is less than 10. So we would be testing that the true mean for the population is less than 10. So we're going to go through a couple examples determining whether or not the alternative hypothesis is one-sided or two-sided. Example number 1 says a machine is supposed to fill bags with an average of 19.2 ounces of candy. The manager of the candy factory wants to be sure that the machine does not consistently underfill or overfill the bags. So our null hypothesis would be that the true mean is equal to 19.2, and the alternative hypothesis is that it is either under or overfilling, so it would be mu does not equal 19.2, and this would be two-sided. Example number 2 says that the survey of study habits and attitudes is a psychological test with scores that range from 0 to 200. The mean score for U.S. college students is a 115. A teacher suspects that older students have better attitudes towards school. So this one's going to be one-sided because it's not saying that they have worse attitudes. It's only looking at better attitudes. So the null hypothesis is that the mean score is 115, so mu equals 115. And the alternative hypothesis is that mu is greater than 115. So the teacher is claiming that it would be better or higher than 115. The last example says that a tablet computer manufacturer claims its batteries last for an average of 10.5 hours when playing videos. The quality control unit wants to find out if the batteries last less than 10.5 hours. So my null hypothesis is that mu is equal to 10.5. My alternative hypothesis is one-sided because we only are testing if it's less than 10.5. The next part of this packet is checking conditions. So the three conditions for proportions were random, large counts, which was n times p had to be greater than, and n times 1 minus p had to be greater than or equal to 10. Then we also had the independent condition, or the 10% condition, that 0.10, or that your sample size had to be less than 0.10 of the population. So your sample size is less than 10% of the total population. The conditions for means is very similar. We have our random condition. Then for normal, instead of large counts, we have the central limit theorem, which is n is greater than or equal to 30, or the distribution is normal. So you can plot the distribution and check if it is a normal bell-shaped curve with no skewedness or outliers. And then last, we also have the 10% condition to check for independence, that the sample size is less than 10% of the population. Okay, so example, we are going to check our conditions. We have been doing this over and over and over again. So it says the Humane Society wants to find out the average weight of cats housed at various shelters in Atlanta. And they take a random sample of 20 cats, and here are the results in ounces. So 6.1 all the way to 10. So we are going to check the conditions. So random, because it says random. For normal, we can say that is normal because it doesn't appear to have any outliers. So no outliers. So even though the sample is less than 30, there are no outliers in this sample, so we can consider it to be normal. And independent, we're going to say that 20 is less than 10% of all cats. All right, so here is our main focus for today, which is calculating and interpreting p-values. And we talked about p-values in Unit 6, and we did have a little bit trouble understanding what a p-value represented. So remember that a p-value is the probability of getting evidence for the alternate hypothesis as strong or stronger than the observed evidence when the null hypothesis is true. So we're saying, okay, well, if the null hypothesis is true, what is the probability of getting our obtained sample? The interpretation is here. You just fill in those blanks. And then to calculate the t to use in the t-test, we are going to do t is equal to x bar minus mu over the standard deviation. So the standard deviation of the population divided by the square root of the sample size. This is very similar. It looks like the z-score of population, where it's value minus mean over standard deviation. Again, make sure you check those conditions. It's important that you check the conditions, or else you cannot run your t-test. Okay, so here is the example we are doing. It says that the level of dissolved oxygen in a stream or river is an important indicator of the water's ability to support aquatic life. A researcher measures the DO, or the dissolved oxygen level, at 15 randomly chosen locations along the stream. Here are the results in milligrams per liter. So, I don't know what that first number is. I will have to check. We'll just say that it is 4. We'll say that that's a 4, so that it's not an outlier. So 4.53, 5.04, and so forth. So an average dissolved level below 5 milligrams puts aquatic life at risk. So our null hypothesis would be that it is equal to 5 milliliters, that mu equals 5. Our alternative, we're just going to look at below. So we would say mu is less than 5. So this is going to be one-sided. So random, checking the random condition, it does say random. Check. Sample size condition. So we have to make sure our sample size is big enough. 1, 2, 3, 4, 5. It says 15, but there's no outliers. So normal, no outliers. So if you had something like 55 instead of 5.55, then you cannot say that it's normal because you have that outlier. And then 10% condition, we're going to say that 15 is less than 10% of, let's see, locations, river locations. Okay, so now we need to calculate the t. Remember that the t is equal to x bar minus mu over the standard deviation of the sample divided by the sample size. You can calculate the sample mean by putting all the values in the calculator and then the calculator does it for you. So if you go stat, enter for edit, I'm going to enter all of these values in the calculator, and then I'll be right back. Okay, so I just entered all of my numbers into the calculator. Then to do the calculations, I do stat, over to calculate, one variable statistics, and my X bar is 4.77. So I have 4.77 minus 5 over the standard deviation of X, which is 0.939, so we'll just say 0.94, over the square root of our sample sizes, which is 15. So then I can put this into the calculator. So 4.77, let's do a fraction, alpha y equals enter, 4.77 minus 5 over another fraction, 0.94, over the square root of 15, and I get negative 0.948. Okay, from here we can use our calculator to find the p-value. To find the p-value in your calculator, you're going to use a function in the variables menu called tcdf. But it's important because when you go to this, so when you do second bars, tcdf, you have to put in your lower bound and your upper bound. If your t-value is negative, like the t-value we got, then your lower bound is going to be negative 1,000, and your upper bound is going to be your t-value. Okay? If your t-value is not negative, so if we would have gotten 0.948, then we use the t-value as the lower bound and 1,000 as the upper bound. So you're either using negative 1,000 to your t-value or your t-value to positive 1,000. So the way this would look like is because I have a negative t-value, that means my lower bound is going to be negative 1,000, and my upper bound is going to be my t-value, which we calculated to be negative 9.48. For the degrees of freedom, remember that you do your sample size minus 1. So for us, it was 15 minus 1, which is 14. Click enter, and we get a p-value of 0.179. So our p-value equals 0.179, and it is one-sided because we are just looking at the less than sign. If it was two-sided, then we would have to double this. Okay? So the p-value, we would interpret that using our sentence stem, which is on this page here. We would say that assuming the mean of the population is 5 milligrams per liter, there is a 0.179, so p-value, probability of getting a sample of 4.77, so our X bar, or less, just by chance in a random sample of 15. So that's a big probability. So because the probability is greater than 0.05, then we would fail to reject the null hypothesis, because we can't say that the null hypothesis, that it's equal to 5, is false, because that's a pretty big probability of obtaining that sample. When you come to class, we will do part 4 together. So make sure you have everything up until part 4 completed coming in.